In question number 6, we're going to need to write the equation in factored form, and since we're given the equation and a hint on the graph, we have a little bit of an advantage. For example, we know that the root that's identified for us is 1, 0, so we can fill that in, knowing that 1, 0 is one of only 2 roots. The other one must be here. We can't really tell what that number is since the graph isn't scaled for us, so we'll have to use some division to help us get there. Before we divide, we can also do another quick part of our answer. We know that the degree of the graph is based on how many directions it goes. It starts out heading down, then heading up, then heading down again, so we know that the direction is 1, 2, 3. We can confirm that from the equation because the highest exponent was x to the third. Now, because 1 was one of the roots, we know that one of the factors would be x minus 1. Again, that's going to give us an advantage because we already know part of our factored form. It's our job to figure out the remaining factors, and we're going to do that by dividing. We're going to use x minus 1 as the side of our division, and we're going to use the original polynomial as the bottom. We're going to set up and divide in order to figure out the top of that division, which will hopefully give us the rest of the factors. If we start our division with x cubed, we know we'll need x squared on top. X squared times negative 1 is negative x squared. And now we look diagonally. Negative x squared and something needs to be negative 5x squared. So we'll need negative 4x squared to complete it. If negative 4x squared is here, we know that negative 4x must have been on top. And negative 4x times negative 1 is positive 4x. Again, we look diagonally. 4x and something must have been 7x. That something must have been 3x. If we have 3x here, that implies we had positive 3 on top, and positive 3 times negative 1 is negative 3. This worked out nicely because in factored form we don't want a remainder, and we didn't need one. That means that x squared minus 4x plus 3 must be the remainder of our factored form. Now, in factored form, we would expect that x squared minus 4x plus 3 could be factored. Sure enough, it's a little diamond problem. Numbers that multiply to 3 and add up to 4 would be negative 3 and negative 1. Since this looks like x minus 3, x minus 1, we also have to take note. We got these two factors from the division, and x minus 1 was already given to us. Now that means x minus 1 shows up twice, once in the given and once from the division, but that actually makes sense, because if x minus 1 is here twice, we would call it x minus 1 squared. And since the graph bounces at 1, it actually makes sense to have that square. So it looks like things are working out. That means if x minus 1 showed up twice and x minus 3 showed up in the division, then in total our factored form is x minus 1 squared and x minus 3. That would imply that if we know the root at positive 1, which happens to be the bounce, that the other root must have been at positive 3. We can always go back and confirm to make sure that it makes sense from the graph. The graph goes through 3, it bounces at 1, and that's exactly what this polynomial equation would tell us.